miles to the west of Sydney Harbour Bridge, a great 6-lane concrete bridge 1,900 feet long is being built by the Department of Main Roads over the Parramatta River. It will replace a narrow 80-year-old steel bridge. The arch of the new bridge, with its clear span of 1,000 feet, is the longest concrete arch yet constructed in the world. Already a temporary steel structure, or falsework, has been erected to support the concrete ribs of the arch. This diagram illustrates how concrete units will be placed one by one on the falsework. At regular intervals, diaphragms or stiffening blocks are placed with the hollow concrete box units. Hydraulic jacks will be placed in special jacking diaphragms at 2 points in each concrete rib to enable the box units to be pressed firmly together and thus forced upwards and free of the falsework. The falsework will then be removed. A short distance downstream at the old Woolwich dock, a site is cleared and developed for the manufacture of the hollow box units and diaphragms. Steel formwork is erected around bases on which the bridge units will be cast. A monorail system distributes concrete from a central mixing plant to all parts of the yard. The concrete is poured directly into the forms for the manufacture of the boxes. Each box weighs approximately 50 tons. The finished boxes are cured with water for several days. Soundness of the finished units is checked with an ultrasonic testing device which measures the time taken for very high-frequency sound waves to pass through the concrete. The stockpile of box units soon builds up. Diaphragms, or stiffening blocks, which are only 2 feet thick, are well reinforced with steel bars. Ducts in the diaphragms will allow steel cables to run the full width of the arch and tie the 4 ribs together. Diaphragms are cast on prepared beds in the same manner as the boxes. A row of completed diaphragms. Samples of all concrete used in the bridge are moulded in steel cylinders for testing purposes. A laboratory for testing has been established at the bridge site, where samples are stored under conditions of constant temperature and humidity until tested. The laboratory is fitted with equipment to measure the strength and other properties of concrete. The ends of each concrete sample are capped with a sulfur compound to provide a smooth surface for subsequent compression tests. The strength of the concrete samples is measured by compression. Special gear at the Woolwich casting yard is employed to lift the boxes onto barges for transport to the bridge site as required. The first box now commences its journey to the bridge. At the site, the box is positioned under electric winches housed at the top of the central falsework tower. The lifting winches first turn the box upright for placing on the falsework. The box is placed on a trolley to move it across onto the falsework. Next onto another trolley, which will lower it down the slope to its final position. This illustration shows the placing of the initial group of boxes before the first diaphragm is lifted for positioning. Diaphragms, unlike the hollow concrete boxes, are solid components except for an opening to allow subsequent access through the rib. The diaphragms will be spaced at intervals of 50 feet to serve the dual purpose of tying the four ribs together and of supporting slender pre-stressed concrete columns which will carry the roadway. As the first diaphragm moves slowly down the falsework, an artist captures progress on the world's longest concrete arch. Using modern survey instruments, units are located with extreme accuracy. And so the first great arch rib progresses. Now another 50-ton diaphragm is inched slowly to its final position. Meanwhile, building of approach spans goes on. This diagram illustrates placing of deck beams on piers with a steel launching truss. The truss is moved forward from the abutment until this vertical leg rests on the pier. While being launched, the weight of the truss is balanced by a deck beam as counterweight. And from diagram to reality, the launching truss with deck beam counterweight is moved to position. The box placing is well advanced, 3 months after commencement. The final box is raised to complete the first of the 4 ribs. This is the 127th unit. So far, some 6,000 tons of concrete have been safely and accurately placed on the steel falsework. After erection of the boxes and diaphragms, the 3-inch spaces between them are filled with concrete. Seen through the opening in one of the diaphragms inside the first huge rib, the side joints are being filled and the rib becomes a continuous concrete span. A model demonstrates the effect of jacking the concrete rib, permitting removal of the falsework. The jacking diaphragms in the rib are expanded by 3 banks of hydraulic jacks. A reserve bank of jacks is not used. This pressure forces the concrete units down on the foundations on each riverbank and causes the rib to rise from the falsework. Note the gap between the rib and the falsework. In a control room on top of the arch, French, English and Australian engineers work together to carry out the jacking operations. Delicate electronic instruments record movements of the arch during jacking. The effect of the expanding jacks is closely examined. Surveyors keep a continuous check while jacking proceeds. All measurements are relayed to the control room. "112 jacks in 2 jacking diaphragms are expanded simultaneously by hydraulic pressure. The arch has finally risen clear of the falsework. Next day, cement grout is pumped into the jacks one by one, replacing the hydraulic fluid. When the cement grout hardens, it keeps the rib permanently in its extended position. The model shows how the falsework is moved in preparation for erection of the second rib. Closely synchronized hydraulic jacks set at each pier slowly draw the falsework along greased rails. Steelwork weighing hundreds of tons and towering 130 feet above water is moved as a single unit, inch by inch, to the second rib position. A central controller with radio telephone link directs the operation. This maneuver will be repeated later for erection of the third and fourth ribs. The falsework is moving from under the first rib. The actual movement, which must be carried out with extreme care, occupies half a day. The falsework now stands ready for the placing of the second rib, as seen in diagrammatic form, from an end elevation. Ribs 3 and 4 are placed in the same manner. The first box arrives for the fourth and last rib. Back at the Woolwich yard, a diaphragm is placed onto the barge for transporting to the bridge. Arriving at the bridge, it is lifted into position. Rain did not halt construction. The access hole in the diaphragm provides transport and shelter for the erection crew. Progress on the construction of the huge arch becomes apparent when seen from the air. The future road system to carry traffic to and from the bridge is taking shape. While work progresses on the arch, construction of the slender shore piers continues. Another crosshead to support the road beams is constructed. A stockpile of road beams awaits the completion of the arch. Placing of components continues in the fourth arch rib. The casting yard at Woolwich is now empty, as the last block awaits transport to the bridge. There are 432 box units and 76 diaphragms, each weighing about 50 tons in the four ribs of the arch. The last of the 508 units is being lifted and winched into position just 1 year after the first box was placed in the first rib. Here, the last box unit slides into position to achieve a triumph of bridge design and construction. The gaps between the diaphragms are now filled in with concrete to form a single unit across the four ribs. Steel cables threaded through the ducts built into the diaphragms are tightened hydraulically. They provide lateral strength and convert the four ribs into a single arch. The world's longest concrete arch, with its crown 135 feet above the river, now stands erect, and the falsework, which served temporarily to hold up each rib, is ready for removal. Soon the carriageways will reach out from each shore of the river to meet in the middle of the arch, and a vital part of Sydney's North Western Expressway will be in use.